Have you ever wondered how Google predicts what you're going to type next, or how your phone recognizes your face? The answer lies in AI, or artificial intelligence. This fascinating field, often viewed as a realm of science fiction, is now a reality that's deeply woven into the fabric of our daily lives. From your social media feeds to your online shopping recommendations, AI is everywhere. But what exactly is AI? Artificial intelligence can be defined as the ability of a machine or a computer program to think and learn. It's the endeavor to replicate or simulate human intelligence in machines. And why is it significant? Because AI has the potential to revolutionize numerous sectors, from healthcare to finance, and even the way we interact with technology. It's transforming our world, making what once seemed impossible, possible. In essence, AI is the science of making machines smart, and it's changing the world as we know it. AI might seem like a recent phenomenon, but its roots go back decades. The journey began with the birth of the concept in the mid-20th century. The term artificial intelligence was coined in 1956 by John McCarthy, an American computer scientist, during the Dartmouth Conference. This marked the official start of AI as a field of study. The next significant milestone came in the late 50s with the invention of the perceptron by Frank Rosenblatt. This was the first model that could learn from its mistakes, a concept that's at the heart of modern AI. However, AI's journey hasn't been all smooth sailing. The late 70s and the mid-80s saw periods known as the AI winters. These were times of reduced funding and interest in AI research due to high expectations not being met. It was a stark reminder that progress often comes in fits and starts, but the field bounced back. The 90s brought a shift in approach from knowledge-based systems to data-driven machine learning. This was spurred by the growing availability of digital data and advancements in computing power. The most transformative development in recent times has been the advent of deep learning in the early 21st century. Inspired by the human brain, deep learning uses artificial neural networks to find patterns in raw data. This breakthrough has led to remarkable advances in areas like image recognition, natural language processing, and autonomous vehicles. Today, AI is an integral part of our daily lives, powering everything from our smartphones to our recommendation systems. It's also a key player in tackling complex global challenges, from climate change to healthcare. From humble beginnings, AI has come a long way, and its journey is far from over. The future holds exciting possibilities as we continue to push the boundaries of what AI can achieve. And remember, every great journey begins with a single step. In the case of AI, that step was taken more than half a century ago, and we're still on that path, exploring, learning, and innovating every day. At the heart of modern AI lies a concept called neural networks. Just as the human brain uses neurons to process and relay information, neural networks employ artificial neurons or nodes to do the same. These nodes are organized in layers, and they communicate with each other, passing on data and information, much like a game of telephone. The first layer, known as the input layer, receives raw data, be it an image, a sound, or a text document. Each node in this layer represents a single piece of that data. For example, in an image, each node might represent a pixel. This layer then passes on the processed data to the next layer, called a hidden layer. Hidden layers are where the magic happens. They transform the input into something the output layer can use. The nodes in these layers apply a set of weights to the input data, altering it as it passes through. These weights are initially set randomly but are adjusted as the network learns, optimizing the output. The final layer, aptly called the output layer, collects the transformed data from the hidden layers and produces the final result. This could be identifying an object in an image, understanding spoken words, or predicting a stock market trend. But how does a neural network learn? It learns by making lots of mistakes initially. It might misidentify a cat as a dog or predict a completely wrong stock market trend. But each time it makes a mistake, it adjusts the weights applied by the hidden layers, making it a little bit less wrong each time. This process of learning from mistakes is called training. So in essence, neural networks are a bit like us. They start knowing very little, make lots of mistakes, but learn from them, and over time, with lots of training, they get better, more precise, and more reliable. Neural networks are the engines that drive the AI revolution. They are the basic building blocks of deep learning, transforming raw data into meaningful information and making it possible for machines to understand, learn, and make decisions in a way that mimics the human brain. But how do these neural networks learn? The answer is deep learning. Deep learning is a subset of machine learning that enables computers to mimic the learning process of the human brain. It's about creating algorithms which can identify patterns within vast amounts of data. But it doesn't stop there. Deep learning goes a step further by introducing the concept of multiple layers of abstraction. In other words, it's like peeling back the layers of an onion. Each layer of a deep learning model abstracts the data a bit more, helping the machine to understand complex patterns and relationships. Imagine a child learning to identify a cat. Initially, they may recognize simple features like fur and forelegs. As they learn more, they start recognizing more complex features, like the shape of the ears or the sound of a meow. This is what deep learning models do, but on a much larger scale and at a much faster pace. Deep learning is the secret sauce that makes AI so powerful. So where is deep learning used? The answer is everywhere. Indeed, deep learning is revolutionizing countless sectors, and its applications are as diverse as they are transformative. Let's explore some of these areas. In image recognition, deep learning algorithms are trained to recognize patterns and features in visual data. It's like teaching a machine to see. These algorithms are used in facial recognition systems, object detection, and even in decoding the visual world for the visually impaired. Next, we have natural language processing. Here, deep learning helps machines grasp the nuances of human language. Think about your favorite voice assistant understanding your commands, or a chatbot providing customer service. That's deep learning at work. Then, we have the exciting world of autonomous vehicles. Deep learning allows self-driving cars to navigate complex road scenarios, recognize traffic signs, and make split-second decisions, all while ensuring passenger safety. In healthcare, deep learning is proving to be a game changer. It's being used to predict disease progression, enhance diagnostic accuracy, and even discover new drugs. For instance, deep learning algorithms can analyze medical images to detect early signs of diseases like cancer, often with greater accuracy than a human eye. Let's not forget finance. Deep learning is used in credit scoring, fraud detection, and algorithmic trading. It can sift through massive amounts of financial data to predict market trends, helping businesses make informed decisions. But that's not all. From climate modeling to music composition, from customer service to cybersecurity, deep learning is paving the way for innovations that were once the stuff of science fiction. In every domain, deep learning is enabling us to solve complex problems, make better decisions, and create solutions that enhance human life. And this is just the beginning. As technology advances, we can expect deep learning to play an even more prominent role in our lives. From identifying cancer cells to driving cars, deep learning is reshaping industries. And as we continue to harness its power, the possibilities are truly limitless. Despite its promise, deep learning is not without its challenges. One major hurdle is data quality. The adage "garbage in, garbage out" holds true. Deep learning models are only as good as the data they're trained on. If the data is biased, incomplete, or inaccurate, the resulting models will be too. Interpretability is another challenge. Deep learning models, especially those with many layers, are often described as black boxes because it's difficult to understand why they make the decisions they do. This lack of transparency can be problematic, particularly when the stakes are high. Then there's the issue of fairness. If not carefully designed and trained, these models can inadvertently perpetuate or amplify societal biases, raising serious ethical concerns. And let's not forget about the computational resources required for training these models, which can be substantial and environmentally taxing. Navigating these challenges is crucial for the responsible use of AI. As we look to the future, AI continues to evolve. The field is buzzing with new advancements and emerging trends that are set to redefine the landscape of artificial intelligence and deep learning. One such trend is reinforcement learning, a type of machine learning where an agent learns to make decisions by interacting with its environment, essentially learning from its mistakes. Next, we have generative models. These are AI models capable of generating new data that mimic the distribution of the original dataset. Imagine creating unique pieces of art or music, or even entirely new product designs, all powered by AI. Lastly, we delve into the realm of explainable AI. As AI systems become more complex, there's a growing need for these systems to be transparent and explainable. This is where explainable AI steps in, making it easier to understand and trust AI decisions. The future of AI is bright and full of possibilities. So that's a whirlwind tour of AI and deep learning. We've journeyed from the inception of artificial intelligence through the intricacies of neural networks to the depths of deep learning. We've explored how these technologies are trained and applied across a multitude of domains, from image recognition to autonomous vehicles, from healthcare to finance. We've also touched upon the challenges they present, including issues of data quality, interpretability, and ethics. But our journey doesn't end here. The future of AI is brimming with possibilities, with emerging trends like reinforcement learning, generative models, and explainable AI promising to push the boundaries even further. This is an exciting field, ever evolving and ripe with opportunities for those willing to delve deeper. So don't just stand on the sidelines. Immerse yourself in this fascinating world. Learn more, explore more, question more. The world of AI awaits. Are you ready to dive in? To